In software engineering, we are taking chapter number 4. We are following the book Software Engineering from Pressman and Maxim. This is process models. Prescriptive process models. So this is a kind of software methodology. The model you have to choose or the process you have to adopt to develop the software. What does prescriptive means? When you go to the doctor, he will give you some prescription. That is, this is the medicine you have to take. These are the things you have to do to get early recovery. So the prescriptive process model, this is all about software development. So this will tell you what will be the structure and what will be the order you have to follow for software development. There are multiple process models we are going to discuss in this prescriptive process model. Again, we are calling it as prescriptive because it is prescribing you what you have to do. It will tell you the set of process elements. Let me give an example. A doctor will tell you that you have to take pantoprazole and domperidone before your breakfast, 1 hour before your breakfast, if you are having trouble of say acidity. But if you take it afterwards, it will not be of much use. So this is the order, structure and all the process elements which is being prescripted to you, right? That is, what are the framework activities, what are the actions, tasks, what will be the work product, what will be the quality assurance you have to follow, adopt, how are you going to control the change. So these are for different projects, small or bigger. So these are the prescription which the model will give. Okay. Now, each process model, it will also tell you whichever model you choose, how will be the flow of process. Process is all about the work, what you're going to do. That is the bigger chunk of work. For example, we learned about the linear process model because framework activity is all about the communication, planning, modeling, construction and deployment. So these were 5 major framework activity. And I also told you activity, framework activity have action, they have task set. But the flow of these activity, framework activity, this model, every model will also tell you what will be the workflow. Okay, it can be linear, it can be iterative, it can be evolutionary, even it can be parallel process flow, right? So these activities, what is the flow? So let me tell you again, a prescriptive process model is all about defining a prescribed set, an ordered set, an indicated set of process elements, and a predictable means you know what kind of workflow you are going to follow in which model, which is better, which is not. The waterfall model. This is also called as classic model, the basic model, the oldest model, the earliest model. Waterfall is all about water coming from or dropping from a height. I'll tell you about this waterfall, but before that, you need to understand that this waterfall model is prescribed only when the requirements for this problem are clearly understood. You know the requirement. For example, you are a developer, there is a consumer or a user. Now the stakeholder or the user has told you these are the requirements and you have totally understood it. So this is a linear, the workflow will be linear. Straight means there will be no circle, no circuit. So let me tell you again, water is always falling due to gravity from top to bottom. It will never go from bottom to top. This will never happen. So similarly, the waterfall model is saying that you have to start with the communication, then planning, then modeling, construction, deployment in a linear fashion from top to down. Let us take an example. Say you already have a software and you are aware that the change or the adaptation, enhancement, emancipation, whatever you have to do, everything you know and the software is also ready. For example, the government says now the tax was 2%, now we are increasing it to 4%. So you are well aware of the situation. We are well aware. So the well-defined adaptation and enhancement for the existing system, you will use the waterfall model. If you're talking about a software from the scratch, that is the new development effort, you can only use waterfall model when the requirements are clear-cut, well-defined, stable, you and the user or the stakeholder have agreed upon, and there is nothing more to tell. So from communication, the first phase of waterfall model, planning, then modeling, construction, and deployment. This is one by one, and this is a proper flow, linear flow, always a linear flow. You can never go back. That is, you always have to go forward. You cannot return back. So the waterfall model, which is, you can imitate it using a waterfall. This is the oldest paradigm of software engineering. That is why we also call it as a classic life cycle model. Classic life cycle model. So this model is suggesting a very systematic means you know it already, right? You have to start from communication till deployment. There is no circuit, as I indicated. There is no circle. There is no repetition. It's systematic. It is sequential, and this will only be done when the requirements are clear, right from the planning to modeling to construction to deployment and even maintenance. Once you give the software, you have to maintain it. So this is the whole process. But there are certain problems with the waterfall model. What are the problems? See, real projects, a realistic project, today's world project, fast-paced project, they rarely follow the sequential flow which the waterfall model is suggesting. Because if you are at design, some requirement has come. In waterfall model, you cannot go back, right? Because these requirements are ever changing. A customer who has come to you, or the stakeholders who have come to you for a website, for an app, or say software, they are not aware of all the requirements. They cannot tell you. No one can tell a requirement in the beginning. Even if you go to the market to take 10 stuff, it is highly likely if you don't write it down, 9 you will be back with 9. 1 you will leave. So requirements cannot be, uphead can be told. And the other problem is, only after construction the actual working version is available. Software is only available when all the sequential systematic flow has taken place. But if there is a problem in between, that is some design issue, some modeling problem, that will be only surfaced when you have already completed the model and you are now at the deployment state. So if the problem or the error is left undetected in between, it will be a disaster. The linear nature, because it is very sequential, very linear, of this classic life cycle model, which we are also calling it as waterfall model, this will lead to a blocking state. That is, if the communications team is preparing SRS, the modeling team and the coding team, what will they do? They are in the blocking state. They may work on some other project, but this project they are blocked. So the project team members or the software development people, they have to wait for other members to complete their dependent tasks. As I indicated you, the software or the application or the website today is fast paced. The life has changed. The changes will come. So the feature, function, information, they are going to change every time. So for that, the waterfall model may not be that much useful. But if you know the requirement, it's always good to use the basic model, which is the oldest tested waterfall model. The V model. So for V model, if you understand the waterfall model, it's just that. This is just a slight variation of waterfall model. As you know, waterfall model is a systematic planned way of software development when we know the requirements. V model is waterfall model plus the quality. So quality added to waterfall model will make a V model. So variation of waterfall model is the V model. So V model is just a slight variation where the quality has been added. So here V model, it is depicting, it is indicating, representing the relationship of the quality issues, quality assurance action, which are associated with the different framework activity right from the communication to modeling till the deployment or before the deployment. That is the construction activity. So V model is adding quality with every aspect or each phases of a waterfall model. I hope you got the idea. Waterfall model plus quality is V model. How do we do this? See, the way it is shown or represented, the V, the letter of English alphabets, V represented. So if I'm taking it as a left and this as a right, this is how V is made. So as a software team will go down or move down to the left side of the V. First of all, the problem will be understood, the requirement will be refined, and then the different aspect or technical representation will be done of the problem for the solution. There is requirement modeling, then the architectural design will be done, modeling you can say. Then you are making the component design, and finally once this is being made, you know the design now, you can just code it. Okay, so this is while you're coming down. Once the code is being generated, now we go up on the right hand side of V. Okay, code generation is okay. Now we move up. Now the software team will move up on the other part of V, the right side of V. And here we are going to perform a various series of tests, and this test is basically the quality assurance. For example, we can have a unit testing, integration testing, system testing, and acceptance testing. For code generation, you can do unit testing, and for component design also you can do unit testing. For architecture and component design, you can do the integration testing. For requirement modeling or architectural design, you can do the system testing. And finally, the requirement modeling or whatever requirement is there on the basis of SRS, you can do the acceptance testing. So while you're coming down, you're making the software. While you're going up, you are checking the software. So this is all about verification and validation. So V model is a visual way you can understand how verification and validation will be applied, or these actions will be applied to all the engineering work, software engineering work, coding work, development work which has been done earlier. Okay, so the quality with waterfall model is V model. There are different testing, even the technical reviews can be done. So V model is all about representation and illustration of how verification and validation actions will be performed or associated with the different phases of engineering action you have taken to build a software. So you see a picture here, parts are being added, or you can say incrementally this product is being made. So this is an example of what we are going to talk, incremental process model. Incremental means you are always adding certain functions and features to the previously made. There are certain situations where the software requirement, the user requirement are quite clear. They are well defined, they are stable, there is no change. Everything is clear. So people will ask, why are you not using the waterfall model? You can use the waterfall model because the requirements are clear. But the problem is the development process or the requirement of the user, it is preventing the linear process, which is the waterfall model kind of use of that process model. That is right from the communication till deployment. You cannot have a linear way because they want something quickly. They will say, okay, just give us some limited features and function, but we want to see the function, software functionality, we want to see very quickly. You may refine it for the later releases. But for now, we want this software as early as possible. Okay. What all other things incremental process models have? The incremental model, it is actually a combination of, or it is combining the element of linear and parallel process flows. I hope you remember when we talked about the linear and parallel process flow. Linear is all about, we can say waterfall model. Parallel is when you can framework activity, take framework activity and do it in parallel. So we are combining this A with the D, the linear process flow with the parallel process flow. This is the incremental model concept. So each linear sequence, right from the communication till the code generation or construction, you are delivering the software and then you are incrementing it. Again, you are following the linear sequence. So the process flow for any increment, this can also be incorporated with the prototyping paradigm. I'm not talking about prototyping paradigm. This is also a process model, but this is an evolutionary type of process model that we'll discuss later. But prototype is all about giving the user the basic functionality so that they have a feel that, okay, this is the software we're going to make. But in incremental model, the first product will be a core product. In prototype, it will be a throwaway. But in the incremental, it will be the core product. Now you will give it to the user. Once you give this first increment to the user is going to evaluate. It goes on multiple evaluation. And then you will plan, and the user will plan that, okay, what we are going to give in the next increment, because we need to fulfill the customer need. And this process will be repeated again and again, because you are delivering each in the increment. Once the complete product with all the functionality, all the features, all the requirements have been made. Okay. So this increment is done multiple times following the sequence rule. I'll give an example of word processing software. Now, if you are giving someone the project of making a word processing software, and the company is going to follow the incremental process model, the core has to be there in the first release, first increment. So these are the multiple increment you can talk about. Maybe in the first increment, you can get the basic file management, the editing facility, the document production functions. This can be given in the first increment. Then you can also give some, added version like PDF so that the user can check whether they want it or not. Then in the second, you can give more editing and document production capabilities. This you can give for the second one. So first increment, you have given user, you get the feedback, they evaluate, then you take those feedback, and then you add more increment, and finally you can give spelling, grammar checking. You have seen when you press Shift F7 in Word or Microsoft Word, you get a Thusaurus spell check. All these are advanced page layout capability. So this can be given in the fourth increment. So these are the multiple increment I'm talking about. This is the incremental process model where we apply or where we combine the linear and the parallel, and every increment will have something for the user. So the incremental model, it will deliver, means the incremental model will deliver releases, and these releases are version 1, version 2, version 3. We also are calling it as an increment, and that will add the functionality. For example, 50 functionalities were there. You give 20 and you get some feedback. You can delete some of them, add more of them. So 20, 10, like this. You can give the customer different releases in increments. Evolutionary process models or software development life cycles. Evolutionary or evolution means going from or changing from certain initial being. For example, human being. We have evolved from, say, monkeys. Similarly, software also evolves over a period of time. Today's business and product requirement, they are ever changing. There is a competition. So every business have very fast and growing needs. For that, if you follow a straight line path, for example, waterfall model, the end product or making of an end product will be unrealistic in the present scenario. It will be very difficult. Today, everyone whenever he comes to you for a software, for an app, or say a website, they need certain limited version, a kind of a prototype, a kind of a working software. In this kind of situation, we need a SDLC or a process model that has been designed and made to incorporate the change, the growing nature of the product and the business needs of your customer. Evolutionary models are iterative. Iterative means loop. For one loop, you will get some version. Another loop, you will get another version. So iterative means going around, taking care of all the SDLC steps, and then you get a one iteration. Again, going through all the steps, you get the second iteration. It's like a loop, for loop or a while loop. So evolutionary process, these are the models. They produce or they give us the increasingly more complete version like version 1, version 2, till the version which is accepted by the user. And in this, each iteration is something added to the previous iteration. Prototype model. If you are an architect and someone comes to you, make my house, will you be starting the work, means to make the house? You will make a model first. Then you will put it in front of the user and then he will get some idea. So when customer just defines the basic objectives, that is, I want to make a home. For example, a software person who wants to make a software, he'll say, I'll want to make a software like this. But he is not aware what are the functions and features he would need. He doesn't know the detailed requirement. So he cannot tell you as a software engineer what functions and feature they want. This is pertaining to the customer. But developer also has certain issues that the algorithm he has used, it might not be efficient. For example, file transfer. Now say 1 MB file he is transferring in 1 minute. Now it is highly likely that for this 1 MB there are algorithms that can take say a second or a millisecond. So the developer is very unsure about the algorithm he'll be using, whether it is efficient or not. So in this kind of scenario, the prototyping paradigm, prototype model, SDLC model is the best approach. So here, the prototyping paradigm will help you as a software engineer and the stakeholder like your customers. You can both understand the issue, the problem, the solution and the requirements. So this prototype is used when the requirements are not clear, they are fuzzy. So all this starts with communication, because in order to know the requirement, you need to talk, you need to communicate, you need to have a meeting. So this communication is the basic aspect. Now, you meet with all the stakeholders, the customers and other stakeholders, then you will decide the overall objective. And then the requirements are known, and then what all other discussions are necessary, because maybe some requirements are still fuzzy. So you need certain more, so say requirement 2 is not clear to you, there's a certain requirement, you need to talk. So prototyping iteration is basically a quick version to be put in front of the user. For that you make a quick design as a software engineer. So here that quick design or quick prototype or quick version of the software is visible to the end user. For example, 1 year is given to you to make a software. In 1 month, you make a prototype just to give a feel what will be the human interface layout, how you're going to click or you are going to interact with the software. What are the formats, output display formats, input formats, how the menus will be there, what will be the working area. So this prototype, the first prototype means actually it's a prototype, not a full version. This is given to the stakeholder. Now he has something in his hand as a user. Now he can give you feedback because he is still not aware of what he wants, but now he can give you feedback. Now you can refine the requirements. Okay. So iteration is, why iteration is done? Iteration is again going back through the same loop, because now you want to fine tune the requirement. Because once the requirement he has given, you need to refine it because the software has to be perfect. For that, you need to be very clear about the requirements. So the prototype, what you are giving, say 1 month, 1 year software, 1 month you are giving, this is all about identifying the clear software requirement, what the user want, what the user function and features you are going to put in the software. So prototype is like a first system, first product you are giving to the user to evaluate. Most of the time, this prototype is a throwaway. Means you will give the prototype, customer will give you feedback and you just throw it in the dustbin. But there are certain projects, this throwaway will become the actual system. This is always possible in the prototype model. So normally, the first prototype is always a throwaway which you just give to be evaluated to clear the requirements. Now both you and as a software engineer and the consumer, they are very happy. Why? They both have some advantages here. First, as a developer, you are getting the software project and you are just starting to work because you are going to make the prototype. You are quite happy. As a user, he is also happy because for 1 or 2 years of project, he is getting the product in just 1 or 2 months. So he can feel it. He can work with it. He knows what he is getting. But the problem with prototype is one. First of all, you will give a working version of the software as a prototype. Okay. Now, when you're making a prototype, you're not considering the quality of the software. You're not putting any effort for the software quality assurance, even for the software engineering aspect like maintainability, etc. So when you give this to the user will say, oh, I want it. Just do these few fixes, put this button here and put this function and give it to me. But the software development management, they know what they have made. So they will relent. They will not give it. There's one more thing. Maybe the algorithm you have used to make a prototype, you might be using some different operating system. You might have used programming language which is not the proper programming language for this particular project. So the OS you are using, the programming language you have, so Java you have used, C# will be better. And the algorithm you have used, they are quite inefficient. Okay. But this will be a part of the system as a prototype, and this will become the final system. So it will become the integral part, and you know that this is not fair. The algorithm is inefficient. So this will become the final software. That is the problem. The spiral model. First, it's not a circular model. It's not a circuit. It's a spiral. Okay. This spiral is the core of this SDLC model. So this is a software development model proposed by the great Barry Boehm. So here we will see different kind of observation people have for this particular model. So I'll take all the observation. So this spiral model is an evolutionary process, software process model. That is, it will evolve. You'll start with a small version, then you will increase. So it includes the waterfall model, the systematic and controlled approach of a waterfall model, and the iterative nature of prototype. Somewhere you will hear that it is iterative plus waterfall model. No, it's a waterfall model with the prototype model, and the prototype will be iterative in nature. The prototype will be iterative. Prototype will go in loops. You will make one prototype, then another prototype, and then you will follow the systematic route of waterfall model. And you know waterfall model have one by one. There is no coming back. But here, when you make a prototype, there is a coming back. From communication till deployment. This is the controlled and systematic waterfall model because it is a well-defined model. But you are adding the prototyping and the iterative nature of prototyping. Okay. So let me tell you, you will hear that this is how this 4 quadrants you will see in a spiral model. First, you have to plan. Now you have a budget. You have to plan according to the budget. You have to plan what will be the development. You have to plan the project. You have to plan the time, cost, schedule, everything, and the test planning. Then you have to determine the goal in the second quadrant. That is, what are the alternatives? What are the constraints beyond which you cannot go? Then finally, the most important part of this spiral model is evaluating the risk. Every time, for every spiral, there is a full quadrant given to the risk analysis. What are the risks? That will cost you the cost, budget, and the time. Then finally, the development and the test. Development test is, you're using all the SDLC part, whichever you choose. Okay, here we'll be using the waterfall model. Okay, the 4th quadrant is all about the waterfall model. So risk analysis is an important part. The 4th one is development test. From here you will start with the requirement, then analysis design, and then you will do the coding, then testing, and finally the deployment. Verification, validation, deployment, like this. So this, how far you go will be the cost. This is the distance, and this is the angular distance is where you are in this spiral model. So what Barry Boehm has said, because he is the creator of this model. So he said, this is a rapid development. Every time we get a complete version of the software, increasingly complete version of the software. So if you have a big project, complex project, the spiral model is a risk-driven process model generator. This is a definition. You don't have to learn it, but just understand. He is saying that it is risk-driven process model. And this is for software-intensive system. So you are applying different concurrent engineering aspect, software engineering aspect here. So this spiral model is different from others. It has 2 distinguishing features. One is a cyclic approach. You see here, it is like a cycle. One cycle you go to complete certain work. Then again, you have to go to another cycle, right? So in cyclic approach, you are incrementally growing the system degree of definition. That is, you are understanding more and then implementing so that you can decrease the risk. The second distinguishing feature is the anchor point milestone. Because once you complete one spiral, there has to be some output. And what is the output? Which is agreed upon and satisfying the consumer. Because you are committed to the stakeholder. So anchor point milestone is you are giving something to them. Okay. Software here in spiral model is developed in series of evolutionary releases. Version 1, version 2, version n. When you start the iterations, iteration is all about looping. You're going all loop once, then again like this. So when you do the early iteration, the release might be a prototype. It can be a model also. That is why we are saying it is iterative nature of prototype plus the waterfall model. So first maybe the prototype, then you go to other different iteration. Here you will give version 2, version 3 like this. Now this spiral model, if we just take the framework activities, because we know the basic SDLC framework activities are communication, planning, modeling, construction, deployment. So how do we define the spiral model with respect to the framework activity? We have to communicate, then plan, then model, then construct. That is, actual coding is done here, and filing the deployment. So how do we use this spiral model? So spiral model is divided into, if you take a circle, let me make a circle, then there are certain segment, you can call it as sector. So every sector will represent the framework activity from communication till deployment. For example, we are starting with communication. So this part, this segment of the spiral is for communication. This particular part will be for communication because you are communicating and getting the requirement from the user. Now you are planning. That is what will be your schedule, time, project planning, the development plan, the test plan, and here you are going to use the risk analysis. This is very important. Then you will go to the third segment, modeling, analysis, design. Then you will go to the fourth, construction, and then you are going to deployment. So this is the clockwise direction you have to go. You'll start with the center. So the software team is going to perform this activity. Every circle you can say, or every spiral activity will give certain result. And every time you have to do the risk analysis. In this case, we are talking about the framework activity. Here we are taking one segment where we will do this risk analysis. And anchor point milestone, as I said, there will be some output, the work product. And for one evolutionary pass, that is one spiral you complete, there will be some milestone. There will be some work product, there will be some release version. And how do we understand this? Initially, we are not much aware. We don't want to develop it. First circuit, you can say that we are developing the product specification or the requirement you are generating. You are understanding the software. This is the first one. You can understand it like this. First spiral, you are trying to generate the requirement. So here also you have to do all the thing. That is, you have to do the risk analysis. You have to do, because maybe first we'll develop a prototype. For that you have to do the development also activity. And every time you do it, every pass, you are adjusting, because this is all about your software manager. You are adjusting the plan. So here the plan can also be adjusted. Most of the SDLC plans cannot be adjusted. Here a plan can be adjusted because you are getting the delivery. And you are saying that you are getting feedback also. So the cost and schedule can be readjusted. So now the project manager will decide how many iterations it wants, because the spiral cannot go on and on. So the first circuit, as I said, can be said as the concept development project. This is the core of the spiral. And then this is the first one. Okay. Because this is a risky project. Maybe it is a complex project. It is a big project. For that, it is mandatory to understand the concept. As I said, this output can be just a model, or it can just be a prototype. Then you move ahead to the next round or iteration of the spiral. Here you are saying that we are actually developing the project. So new product development project. Third, it can be enhancement, because once you have developed, it can be enhancement. You need to enhance the software because the changes or the requirement can come. And finally, the other spiral, the outward spiral, can be the support or the maintenance, product maintenance project, you can say. So this spiral model is a realistic approach, what you see here, for large scale system, big softwares. And here we use the prototyping, very important, the iterative nature of prototyping for a risk reduction. Because if you make the whole software and there is a problem, you will lose the time and budget. So better to make a prototype and put it in front of the user. There will be a risk reduction, and even the software team will know what are the risks. So here we are applying the prototype approach for risk reduction every time, because it is iterative prototyping. Okay, it is not iterative. No, it is prototyping iteration. So you can do the prototyping at any stage of the software development lifecycle, here framework activities. So it also, once you have done this prototyping, then you will maintain the classic life cycle. So classic life cycle is the waterfall model. You will start with communication, planning, modeling, construction, deployment in a serial manner. Okay, so every time you may have a prototype in between also. So the problem with spiral model is, first of all, you can see it's quite complex. But it is for the complex project. It is very difficult to convince the customer, because customer may not know certain things, that you can control it or not. And the main part of this spiral model is risk analysis. If you know the quadrant I told you earlier, there is one part whole dedicated to risk analysis. If the person who is dedicated to the work, he may not be competent to find out the risk, and that will be a disaster, because the risk analysis is the core part of the spiral model. If the major risks remain uncovered, the problem, the cost, the estimation will all fail. So this is the spiral model problems, but still it is being used widely. Concurrent models. So this is also one type of software development life cycle. Concurrent means all the framework activities, all the phases of the software development will go concurrent. So this we also called as concurrent engineering. So here we are talking about the iterative, that is looping one by one, and then concurrent elements of any of the process models. Any process models you can talk. We will talk about spiral. So here we have a spiral model. Any framework activity will start with communication, then planning, then modeling, and construction, and then deployment. So these are the different states. Every framework activity will be in certain states. All will be in concurrent, means all will be there, but in different, say awaiting changes, say under review, say under development, inactive, done, baseline. These are the different states. But every activity will have certain state, and they will be there concurrently. So let us take an example. Now, if you are working, or say you are walking. Now your friend comes, you start standing. You are standing now. When you are done with your talk, you again start walking. So this is how your states are changing, depending upon certain trigger, depending upon certain event. So all these different phases will be in certain state. Okay. So if modeling is taken, if modeling is at certain state, the communication and construction will also be in certain state. If one can be at under development, other can be at done, the other can be in under review. If we start with communication, whenever a project starts, there will be communication activity. Now, if the communication activity, the requirements have been taken, and now we are saying that it is completed. We are going through an iteration, number of iteration, and we say the communication has been completed. It's complete. So now this will go in the done state, or it can go into awaiting changes. Because why not done but awaiting changes? Because after communication activity, there will be certain requirements, communication will come. Okay. Now, the modeling activity. When communication was happening, the modeling was at none state, or you can say inactive state. Now this modeling activity will get transited or will be transitioned to under development state. When communication was there, modeling was at an active state, but communication happened, now it is under development. Some more changes are coming. If some more changes are coming in the requirement, so the modeling activity which was under development, now it can be transferred to the awaiting changes state, because now the communication activity has to take place. So now communication activity will become active. Okay. So you understood this. There are certain triggers. So concurrent modeling is all about defining what are the events, what are the triggers which will transition the different framework activity and what activities, action and task will be done accordingly. Okay. During the early stage of design, if some inconsistency is there, say some requirement model problem is there, so this will again trigger the requirement analysis action from done, because we say, oh, because all our requirements have been taken, so it will go to awaiting changes, because now the changes will go into under revision, under review, like this. So what I am trying to suggest here is every phase concurrent and will be in certain stage, certain phase or event will trigger all of them. Okay, will change the state according to the activity which is upcoming during the course of the software development, right? And this is the figure I am trying to talk about, modeling activity. It can be for any of the activity. Specialized process models. So we have a waterfall model, spiral model, prototype. We talked about all these. But what are these specialized process models? These software development life cycle, they will be employed, they will be used for some specific cases, not for every general cases. So this specialized process model, they are taking the good characteristics or many of the characteristics of different traditional model. Say from waterfall model, from spiral model, like this. And as I said, these specialized models will be applied only where certain software has to be made, specialized software has to be made, and where very specific kind of software engineering is involved. We'll talk about in specialized models, the component-based models, component-based software development. Then we have the formal methods model. This is also an SDLC. Then we have aspect-oriented software development. Component-based development, software development life cycle. So you might have heard about the game Lego. So the kids get a lot of parts and they can fit together. So when the kids fit it together, it will be some animal, it will be a car, it will be some fighter aircraft, like this. So these are the components, these are the different parts. So what up till now, what has happened? Various vendors, various companies, software companies, they have already created the commercial off-the-shelf COTS software components. For example, the payment gateway is already there. So if you make a website, some e-commerce website, now the payment part, you don't need to build it because it is already available as a software component commercially. You can just go and buy. You can just buy it, right? So these are already well-defined interfaces they have, these payment gateway, these commercial off-the-shelf components, and they can be easily taken and easily integrated into your software. And this component-based development model, various characteristics of spiral model is incorporated. So the way we develop using the component-based, this is using the spiral model basic characteristics. And since we are talking about spiral model, it is evolutionary. That is why it has to be iterative approach, because most of the time we'll combine 2 components and 3 components like this to make a complete software after combining all the components. So this modeling and construction activity will contain what? What are the candidate components? What all components you have to fit? So if you want to fit a software, which component, which part you want to make it more complete? Okay. So these components, as I said, it can be a calendar, if as small as calendar, it can be a payment gateway, it can be some conventional software modules that I just talked about. Okay. Along with this, we have the object-oriented classes, it can be taken, or the class packages can be taken. All these are called as components only. So this component-based development model, it follows certain steps. The first one is, what are the available components, whether it are available as a COTS in the market, or whether you are going to make it or take it from your some company, so as a sister company. So you have to research it, and then this component integration, because this model is all about taking component and combining it. So what will be the integration issues? What will be the problem arise? What will be the risk, etc. Then some architecture you have made properly. So a car architecture, for example, you are making, so you need where to put the tires, where to put the engine, in the front or the back. So there will be software architecture, because now you are trying to fit in these components. So where to fit it? For that you will have some component architecture, software architecture, and these now components are integrated as per the architecture you have made or as per the design you have made. And then when you are combining them, you have to do comprehensive testing, because what you have decided or you have desired, the functionality should be like this. So component based modeling or this development is all about software reuse, because once you reuse, your time will be less and the project cost will be less. You don't need to start everything from the scratch, and you don't need to reinvent the wheel. For example, here you see this is a holiday reservation, or you can say the hotel reservation. So credit card billing is already made, reservation is already made, loyalty program is already made. So just take it as a component and fit it, and then just test it. The formal methods model. Formal method. So here we are talking about putting formal mathematical specification. You will not write mostly in English. If I talk about, say, digital 1 and 0, it can be only true and false. There will be no ambiguity. If I say 2 plus 3 is 5, if you write this in the specification, there is no chance of any inconsistency, any ambiguity. So you are using the formal mathematical specification to write, to requirement, to write the design, to write the everything, to make a software. So formal method is all about specifying, developing and verifying the computer based system by applying your mathematical notation, as I just suggested. It can be any kind of mathematical notation, symbol notation, or some algebra notation. So these formal methods, there are certain things for specification also, that you are writing the specification, the user requirement in certain formal method, mathematical notation model. And then you are also writing for verification, that this has to be verified in the mathematical way. So there is one important clean room software engineering, and this is nothing but this variation of approach. Why it is clean room? Because there can be some problems, some ambiguity, some inconsistency in SDLC, different SDLC, but here it will not be there. So all the earlier problems can be removed in this. As I said, requirement you are not understanding, or the user is saying something. So the user is asking for Jupiter, you are giving Saturn. So ambiguity, incompleteness, sometimes you don't write it. Sometimes the consistency is not there. Somewhere it is different. Other time it is different. Somewhere you are writing 2 plus 3 is 6. Somewhere you are writing 2 plus 3 is 5. So now this is mathematical analysis you are putting. It can be corrected. It can be forcefully said that this is not a mainstream approach. Okay. But if I'm using formal method model, I can promise a defect-free software. This is promise because you are using mathematics to define the requirement. You are using the mathematical notation for verifying also. So the problem or the concern about the formal methods, first of all, mathematics, we know all. Writing the requirements and all these documents in mathematical notation and understanding is time consuming, it's expensive, and to write, to evaluate, to understand, you have to have extensive training. It means software developer needs to be given extensive training. And the communication mechanism, how do you convey? If you are using use case or requirement specification, it is how it will be understood by an unsophisticated customer. The customer will come and he will try to understand what is this at the rate, what is this is equal to tilde sign, relational algebra, all these kind of algebra, how he is going to understand. So these formal methods are used where the safety critical software you are making. For example, the developers who are making the aircraft avionics software, medical devices where the life and death is involved, and where if the software fails, there will be a hard hit economically on the company. So that is why we use the formal methods model, where life, death, and immense economics is involved. Aspect-oriented software development. Now this is a software development life cycle, and this is also specialized. That is, it will be used in certain specialized software only. So there will be certain word which will come. One thing is aspect. So the aspect, you might have heard about object-oriented software development. So everything will be based on the object. in object-oriented software development. You'll make a class, you'll make an object, and everything will be accessed through the object. In the same way, aspect, here we are talking about software development lifecycle. We are talking about dimensions. We are talking about phases. Okay. So now today, the computer-based system are so sophisticated. They are so complex. They are so modern. There are various concerns, phases, dimensions that the customer are providing. And the technical interest, there will be hardware, there will be electronics involved, there will be, say, communication involved, communication technology. All these are there. So the entire architecture has to be considered. See, let me tell you about this aspect or the concern. Just understand the phases, dimension, whatever is there, concern we are talking about, the aspect we are talking about. Some aspects, some thoughts to the software are only limited to high level. That is, for whole software, the high level thought concern is the security and the fault tolerance. Okay. And the other concern can be they are affecting the functions. For example, it will not be high level. It will be just affecting certain functions like application of business rules. Okay. The business rules can be what is the percentage of interest and the tax cut rate, all these. So it will be, this concern is only limited to the functions. There are other concerns for the software. It can be systematic. There is the task has to be synchronized. The memory management has to be there. Now, the important word here in aspect oriented is cross-cutting concern. So all these concerns which we say, whenever they intersect each other, this is cross-cutting. So we are talking about the security. Now this security is involved, or it will be concerned to this function and this function. And when this security is concerning to these two functions, memory management is also affecting this first function. So what I'm saying is the security aspect, high level, and the systematic concerns, they are affecting, or they will be affected to certain function, and this is the cross-cutting concern. So aspectual requirement, this defines these cross-cutting concerns that have impact across the software architecture, because when you're making the software architecture, you will be talking what are the aspects which are going one over another, coinciding or intersecting. This is cross-cutting. So this is a legacy program which I am trying to suggest. This is the cross-cutting concern for the legacy program. But in an aspect-oriented program, here we always evolve the base code, but here the evolution of aspect will be there, because these are different aspect, high-level aspect, function aspect, systematic aspects. So no, these circles are not, they have some intersection points. So aspect-oriented software development, aspect-oriented programming, aspect-oriented component engineering, AOCE, they all are same. So the names are changed, but they all are saying one thing. That in a software development life cycle, we start with the communication, then we say we plan, then we do the modeling, the designing, and then we do the construction, actual development, and then we do the deployment. So here the AOSD, AOP or AOCE, this is all about specifying, telling you what will be the method. Okay. So this is all about, see, here we are talking about not all the framework activity. We are talking about DSDC, right? That is defining, specifying, designing, and constructing. These are the aspects we are talking about. We're not talking about all these. We are saying previously we were doing subroutines, we are inheriting certain functions and the classes. Here we are talking about what are the process and methodological approach for defining, specifying, and designing, constructing aspects so that the cross-cutting concern can be addressed. So the evolutionary model is very appropriate here, because the aspect have to be identified and we have to construct it. So the evolutionary model is quite good in this case for AOSD, AOP, and AOCE. And then we have to have a parallel nature of the concurrent development. This is very essential because the aspects are engineered independently of the localized software components. And here the aspects have a direct impact on these functions, the components, etc. So here we just have a DSDC, not CPMCD. Unified process. So before we go to unified process, let me tell you about these three gentlemen. Okay. First is the Grady Booch, Dr. James Rambaugh, and Dr. Ivar Jacobson. in different parts of the world, they were doing the work on the same thing. Object-oriented paradigm, object-oriented related stuff. And this early 1990s, these three gentlemen, they started working together for a unified method. And as I said, they were working on object-oriented paradigm, analysis, design methods, etc. So they thought, let us take the best features, what we have thought and developed, and let us combine them. And then finally, they proposed, because all these proposals were by different people also. So they combined their thoughts and those proposed by various experts in this field of object-oriented modeling. So when they combined, they sat together, and what was the result? The result was a de facto language or the notation which we use everywhere now in software engineering. This is Unified Modeling Language, UML. So the result was UML. This is the Unified Modeling Language, and this has all the notation right from the specification till your requirement, till your modeling, design, and your testing. Everything is there. So this is a robust notation for the modeling and development of object-oriented system. By 1997, this UML has become a de facto industry standard for object-oriented software development till we are using Unified Modeling Language to various aspects of software engineering. The unified process. This is also an SDLC, software development lifecycle process. So here we have to talk about these three gentlemen, Grady Booch, Dr. James Rumbaugh, and Dr. E.R. Jacobson. Now the seminal book is something which is turning point in the technology. So in his book, or all of them have written, Unified Process. So they were discussing and they were onto object-oriented paradigm. So when it comes to software engineering, software process, they said we need a use case driven, architecture centric, that is the architecture should be important, and iterative means multiple times we have to do this process and every time we have to give added functionality, incremental. So let me tell you, these words will come again and again. First, the user. So use case driven. I'll show you what use case means, because all the requirements will come from user and it has to be very clear to represent it and to follow it. Then we have architecture centric. If you want to make a home, you have to make a model first, architecture first. Iterative means doing it multiple times so that you refine it and then you increment it. So all these content, what they have said, the brief is the software and the software industry, the hardware industry is growing every day. So we need the software, we need the business needs to be fulfilled, the user need to be fulfilled. In terms of software, that has to be made fast and should be efficient. So in short, they were asking for more from the software engineering paradigm. So unified process, they are saying, and this process is all about good things taken from the traditional software process. Waterfall model, spiral, prototype, we all talked about this. So the best features and the characteristic, the good things of these traditional software processes has been taken, but the best principle of agile software development was also implemented here. Agile is all about flexibility, the software development which is quite flexible and it changes according to the requirement and it is fast paced. We'll be talking about agile in the next discussion. So whenever we are talking about, please remember there are certain framework activities. Any model you talk about, it will start from communication, that is you have to talk to the people, stakeholders, then you have to plan everything like the project plan and the test plan, etc. Then you have to make the model, because that model and that architecture is going to be coding and testing is the construction part, and then we have the deployment part, giving it to the user. So the unified process, the first thing they recognized, or the unified process is about getting requirement. That is talking to the customer, the stakeholder. That is, you have to describe what the user wants from the system. So how the user will perceive it, what the user wants. For that, we have to make the use cases. So for that, this use case will be written in a UML. These all three gentlemen were responsible for this unified modeling language. So this is how the use case, one of the example I'm saying, this is the online shopping system, how the user or the customer will interact with the system and other stakeholders, other people who are in, say, directly or indirectly related with the software, how they are going to see the system, interact with the system. Okay. So the second thing comes is software architecture. They emphasized on architecture. That is, if you want to make a house, how the house will look like. So if you want to make a software, how the structure, the model, the aspects of software architecture will be conceived. Then only you can think about the goals, the understandability, how we are going to handle the changes, and also reusability. So reusability is the component already being there. You can just use it for reusability purpose. So the process flow, because we talked about multiple process flow, this is iterative and incremental. Iterative means doing it again and again. Incremental means every time you produce something which is higher version than the previous one. That is how you get an evolutionary feel of today's modern development scenario of software development. So I'll tell you about this picture. This is the unified process. Here on the left side, you see the normal framework activity you do. Okay. But now when in terms of unified process, they called combination of certain framework activities as inception. So inception is combination of certain activity of the framework activity, like the from communication to deployment. And requirements, see, in the inception part, the business modeling is going on, the requirement is going on. Some part of analysis design like this. Elaboration, these are different from business modeling to deployment, they are activities, but E1 is the first iteration, E2 is another iteration. For elaboration, it can go for E3, E4 like this. For example, in construction, all these activities are going on, but the iteration is C1, C2, C3, C4, and C4 is the final iterative increment, and then transition. So all these classical activities are added somewhere. So we'll start with the inception phase. The inception phase of this UP, we'll call it as UP. Here the communication and the planning activity of the earlier SDLCs were combined. The framework activities were combined. So they were called as inception, communication plus planning. Here, what is going to be done? First, you have to talk with the stakeholders. First, you have to identify the business requirement. Then a rough architecture, not of the full architecture, but a rough architecture has to be proposed and to be made. Then iterative, incremental nature, how you are going to achieve. This you have to finalize here in the inception case. Okay. Then the preliminary use case, because now you have got some requirements. What are the features and function a user would want? A person who is interacting with the user, this software will want. Then in this architecture, you have to outline the major subsystem. I'm not talking about the detail, but major part of that. For example, a car, the engine is the main part. We're not talking about a filter. Okay, the air filter, that will come later. Those are coming later. Then this architecture will be more refined, because there will be multiple aspects and the views from different stakeholders. Even your view is important as a software engineer. So here, because I am saying communication, planning, both are there. So in planning, we will identify the resources, how many people we have, what all computers we have, mainframes we have. Then we have to see what risks are involved, what are the major risks. Here we'll talk about major risks. Then we have to define a schedule because time is limited, and how we are going to achieve the increment. Then comes the elaboration phase. Elaboration phase, one example I have given here, one iteration in the elaboration phase. That is, there are multiple iterations, 1, 2, 3. So one iteration will take say core workflows. So elaboration phase is combining the communication and modeling activity of the classic models, or you can say the framework activity. Okay, of the generic process model, you can say. So this elaboration, because we already made some use cases in the inception phase, and now we have to refine and just expand these use cases which are already done in the inception case. And since inception case we have a rough idea of architecture, you have to increase it. Now you have to go to the model. You have to make use case model in UML, this unified modeling language. All this modeling, implementation, deployment model. So here, most of the time, we get the first cut executable system in the elaboration, most of the cases. Now, we have to plan, because this is planning also, that we have already talked about the inception, the scope, risk and delivery dates. Now we have to see whether it is reasonable or not, and if some change is there, how can we cope up with that. So in this, for example, 2 years, you cannot give the project in 4 years. You have to complete it before 2 years, say 1 to quarter years like this. Now the construction phase, the coding activity is done here. So construction is construction only. There is no combination. Because construction is construction. Here, because already architectural model is developed, we'll take the input of this modeling, and now we are going to construct. Because there may be some component modeling taking place, so we have to use the component, and we have to use the code which are being developed by us, and we have to make all the use cases operational. Okay. For that, we have to input this analysis, design, etc. And now we'll see what features and functions are required. All the necessary. We cannot leave anything here. We will take the car filter here. Okay. This also has to be implemented. And then once the software code is implemented, component are being bought, or codes are being bought, you have to decide for the testing. For example, you wrote some function, I wrote some function. We have to combine it. And when we combine it, we need to go for certain testing. It can be unit testing. It can be integration testing. Actually, all these testing integration activities has to be done here in the construction phase. So development and testing will be done here. And then we have to develop the acceptance test also. Because the user will accept only on behalf of certain acceptance test. So this has to be prepared also in this phase. Coming to the transition phase. So what is the transition phase? We are combining the construction and deployment. To be very precise, the last of construction and the initiation of deployment. This is the part of the transition actually we are calling. That is the later stages of the construction and previous cases of the deployment. So now software will be given to the user for beta testing. They will check it, they will verify it, they'll get back to you for the defects and whatever necessary changes they would like to have in your software. Now, as the software is ready, you have to give all the documentation, software engineering products. For example, user manual, user guide, troubleshooting guides, installation procedures, and other documents which are required, like the SRS, you don't have to give the design, but if they want, that is also there. Then coming to the production phase, so there is also only one activity which is coinciding with the framework activity, that is the deployment activity. So here, once your software is working, you have to support, and you have to, because in between also you'll get some defect reports and certain changes. This will be given to you, you have to evaluate, you have to do it or not. And see, at the same time, the construction, transition and production is going on. Other activity can also be done. That is, we have already started the software increment while these activities are going on. So what I'm saying is, in UP, all these are going on, not in sequence, but in staggered concurrency, because concurrency is like this, but staggered concurrency is like this. So software engineering workflow, see, workflow, task set, this already we discussed about. Task set we started with the framework activity. Every activity will have some action will have some task set is the actual work you are going to do. So you can say that the workflow or the task set are analogous here. So what actions we have to do, what actions will produce what task set, and what task set will give you what work product. So all these has to be revisited here, because ultimately you have to meet the end of the user. Personal and team process models. So we discussed about various SDLCs, software development life cycle, that is waterfall model, prototype, and spiral, etc. So these are the process models. But when we are talking about team and individuals, because any project will be undertaken by a team, the project will be done or completed by a team, and this team will have individuals. So for team, the models which are taken are team process models, and for the individuals, those who are working inside the team, if we talk about individuals, then it's PSP. Okay, we are talking about personal process model, right? So PSP is for individual, TSP is for team. The idea is the team can itself create its own process. Okay, because they are going to follow a certain need, and if an individual is creating its own process, following certain own process, actually the individual it is doing perfectly, then it will be helping the organization, because this organization is made up of these individuals only. So we can create a PSP or personal software process, or you can say, and also because we are talking about team software process. Okay, both require hard working, training and coordination. Why? Because you need to train everyone, you need to train the team, but both are achievable. So again, for single, it's single PSP, for team, it's TSP. Personal software processes. So the software processes followed by, to be followed by an individual, a single person. So this PSP is emphasizing a personal measurement, single individual we are talking about. Measurement of the output, whatever it is doing, the work product. He may be a coder, he may be a designer, or he may be a quality person, or a person doing some work can also take care of the quality. So this PSP makes this practitioner, that is the people who are actually coding and actually creating the work product, they are responsible for project planning. That is, they will estimate also and schedule also, and also control the quality of whatever product they are producing. So we are talking about individuals here. Please remember, PSP is defining, this kind of model is defining 5 framework activities. So an individual, what are the phases of PSP model? Defines 5 framework activities. The first one is planning. So planning is all about isolating the requirement or knowing the requirement. Then developing the size and the resource estimates. Various metrics will come here. For example, in 2 years I will complete, 2 months I will complete, 50,000 or any amount. Then we have to estimate the defect. That is, how many defects this we can project. That okay, 10 defects will be there, 20 defects will be there. And all these matrix, as I said, estimates, all these estimates have to be recorded on a separate worksheet or a template which is made by individuals, team, or pre-made. Then the development task is done. Okay, first it has to be identified, and then the project schedule is created in planning. That is an individual, how long it will take. Coming to high level design. So in high level design, the external specification, because the requirement has come. So we are talking about external specification, and we are talking about component design here. What all component will be constructed and developed. And if there is a problem, that is some uncertainty is there, we'll try to create a prototype so that we know a priori that there will be certain problems, how to deal with them. And as I said, all issues have to be recorded and tracked. Of course, the manager is already there, always there. But PSP is for individuals. High level design review. Now how to review? So here we will adopt the formal verification methods. In software testing, there are certain formal verification methods. Type system, symbolic execution, proof assistance. We'll talk about that later. These are applied because we want to find out the bugs, the errors in the design, the problem in the design. So the metrics, again, we have to maintain. All the important tasks, what are the result we are going to get? We have to follow and write these metrics, okay, in the high level design review. Then the development. Now, because we talked about component designing, so component level design, it needs to be refined here and it has to be reviewed. An individual can create one component, it may be refined, it may be reviewed. Then a code has to be generated, it needs to be reviewed, it needs to be compiled, run and tested. Again, same thing, metrics have to be maintained because there are certain output by individual and there will be certain result by the individual. Okay, so the template I talked about. Then coming to post-mortem. If somebody dies, the post-mortem is done to know what is the cause, what is the reason. So as we are collecting, measuring, estimating all the metrics we have collected, then we will see the process, whatever we have adopted, what is the effectiveness of this process, because we are talking about different kind of processes. Anyone can take, you can take any other process, I can take any other process. So we need to find out the effectiveness. And these measures and metrics which we are following right from the first planning, high level design review, and then development. Okay. So this will guide us how to improve its effectiveness of the process. Because we are trying to find out, we need to do better. PSP, as you might have understood now, that this is all about identifying the problems, error early. Okay? Because we have to, that is why we have metrics and measurement, etc. And the individual is said, you have to find out the defect estimate. So for that, we need some good assessment type of activity. And this will be done on all the work products. For PSP, a rigorous assessment activity is there. But the situation is PSP is not widely adopted. The problem, first of all, as you said, and we discussed, that the intellect has to be high. Because PSP is all about, estimating, finding errors, demand a lot of, values to be put. So first you have to be committed to do that, and intellectually you have to be smart also. And this is both for a practitioner and a manager. They are also individuals. You can just train them also if you want for PSP, but the training is quite lengthy. The training requires a lot of money. So the cost of training and the length is quite high. And the problem, one more problem, is the required level of measurement is culturally difficult for many software people. Software people learn something different, right? Now we talked about PSP, and this PSP and TSP go hand in hand. So we are talking about team software process. PSP is about personal or single individual practitioner or manager. But when we talk about TSP, we are talking about whole team. There can be multiple teams or there can be single team working on a project, right? So whatever we are going to talk about, just assume it to be pertaining to all of the team. So goal of the TSP is to build a self-directed project team. Self-directed means the project team will decide what to do, how to organize, how to plan, because they have to produce a high quality software. In Waterfall, we know what to do. In Spiral, we know what to do. But here, the team will decide. So Humphrey, he gave certain objectives of this TSP. First, the thing we started is self-directed. So the first thing is to build self-directed team that will plan and track their work. They will establish the goals and own their processes and plans because it's teamwork. The team. So this can be a pure software team. It can be software along with some other team, integrated product team. So 3 to 20 engineers. This is what Humphrey has suggested. And this shows, because manager have to guide. First of all, you have to coach and motivate and teach your team. That is how to get the peak performance. You need coach for your hockey team, for your cricket team. That's how. And how to accelerate, how to do the software improvement so that the company or the organization or the team achieves the CMM level 5. We'll talk about the CMM. There are different levels: initial, managed, defined, quantitatively managed, and optimizing. So this is the optimizing level we are talking about, because we want the high maturity organization of level 5. So these are the objectives of TSP, team software processes, because all is done to improve the product. Because he also suggested that this can also be given in the university level. So it will facilitate university teaching of industrial grade team skills. Okay. So TSP we talked about. The self-directed team is the core. And when the team is by itself self-directed, it has all the idea of what is their goal and what do they want to achieve, objectives. So this TSP is highly dependent on PSP, and PSP corresponds to TSP. So the team being formed by the individuals, they have to have a clear understanding of what they want to achieve. What are their goals and objectives? So this self-directed team will define the role and responsibility of each single team member. It will track the quantitative project data about productivity and quality. That is, I'm not just talking about project. We are talking about quantitative data of the project. Okay. And it will identify team process, because the project can have multiple processes. What is the best process will follow and how to implement it. It also defines the local standard applicable to the team software engineering work. That is, what other standards we can apply. And then the risk assessment and how to react, how to minimize this risk or to completely, get rid of that risk. So finally, the whole idea is to track, manage and report the project status. So TSP also defines certain framework activity: project launch, high level design, implementation, integration, test, and postmortem. The postmortem is all about process improvement, that CMM we talked about. This is TSP. So TSP uses what? It uses a wide variety of the script, the forms, and the standard, because there have to be certain criteria, the way, standards to guide the team, because this is the standard we have to follow. These are the script. This is the form we have to follow. So script is all about a specific project activity. That when will be the project will launch, what will be the design, how we are going to implement it, integration, system testing, and the postmortem. This will be there in the script. And script will also contain various work functions, detailed, that is, what will be the development planning, what is the requirement development, if some changes there are software configuration management, and the unit testing. So TSP is all about how the team will be self-directed. Okay, the best team will be best team which is self-directed. The team members, they will set their own objective. They will try to adapt the process to meet their need, control and project schedule. And this is done through measurement and all the analysis of the metrics which are being collected. That is why we have to talk about PSP also here. And then we will want to improve the team approach, because this is all about putting the software engineering in place to get a good product. Process technology. So as we talked about process, it is a layered technology. So we have tools, methods, process, and quality focus. So process technology tool, this will help and allow a software organization to build an automated model of the process framework, task set, umbrella activity. So this all comes in the SDLC, software development lifecycle. So in this SDLC, we have framework activities, task set, umbrella activities, actions. So the model we are talking about is, we are representing it using a network, and this is showing the workflow. It can be iterative, it can be serial, right? And then we will examine alternative process structure that might lead to reduced development time or cost. Once we have decided the process, there are other process technology tools. It's all about tools. Now this can be used to allocate, monitor, and also control the software engineering activities, actions, and the task. Because what we have defined in process model, this also has to be allocated, monitored, and controlled. And here we are talking about each member of a software team can use these tools, the top layer, to develop a checklist of work they have performed, work product they have produced, and what is the quality assurance activity to be conducted. So this, you just have to know, with this discussion, we are talking about the tools that will help you to take the software engineering activities, or put these software engineering activities into the software development, because all about is time and cost management. So this is all about this discussion. Thank you so much. Take care of yourself.